All right, this is 2.2. You have a quiz on Thursday, and then you have a test on Monday. These are the only two things on your quiz and test, okay? So it should be a fairly short unit, a fairly simple one, hopefully. So here we go. What 2.2 is linear programming. This is real life application and how I can do this, okay? I also put 2 YouTube videos on your Schoology of more examples and somebody who walks through real life examples. So today we are just going to be doing graphing. Tomorrow we will do the real life word problems. Okay? So linear programming is a method for finding. I have my notes, I did them. I did this last night. I stayed up and did it. Are you kidding me? Alright. Linear programming is a method for finding the maximum or minimum values of an objective function over a given system of inequalities. Why not? Given system of inequalities, okay? So we will be graphing inequalities. And you have to remember how to graph inequalities. What's the difference between an equal inequality and a non-equal inequality when you graph? Does anybody remember? A dotted or a solid line. Very good. Okay? Alright. Each inequality represents a constraint. The solution set of a system is called the feasible region. And the vertices are used to determine the maximum and minimum values. So these are just 2 different types of graphs. This graph on the left is called a bound graph, meaning it has borders on every side of the feasible region. Okay? So you should know these things, but where all of your lines meet are called your vertex or your vertices. The shaded area is your feasible region. And then all the lines are your constraints, which were your inequalities. The graph on the right is an unbound graph. Which really those words go down here. Sorry. The feasible region is enclosed or bound. I wrote them at the top instead of down there. The maximum or minimum value always occurs at the vertex of the feasible region. So our unbound graph has the same things. Your vertex are all these points where your lines meet. Your constraints are still the lines. That's the box at the top. That's pointing to your lines or your inequalities. And then still the shaded area is the feasible region. So in your unbound, it can open or go down and go on forever. It's just unbounded, meaning it doesn't have a constraint on one side. This is the most important thing. Unbound regions have a max or a min. They won't have both. It will have one or the other. Okay? One or the other. So let's go do 2 examples at the bottom down here. It says, graph the system of inequalities. Name the coordinates of the vertices of the feasible region. You will find the maximum or minimum of the function for each region. So this right here gives me 3 constraints. This bottom function is our objective function, meaning that's the function we want to know will have a maximum or / and a minimum. Okay? So first constraint, y is less than or equal to 4. Is that a vertical or a horizontal line? A horizontal. It has to cut the y-axis. So at y is 4, I'm going to draw my horizontal line, and a line has arrows on the end. Now, in Algebra 2, when you learn this, you shade, and then you have what's called a double shaded region. Here, because we have more than 2, you can have 5, 6, 7 constraints, okay? It would be very messy to keep shading and shading and shading. So you have 2 choices. Number 1, you draw all your lines and then figure out where your shading goes, or you make little symbols on your graph. That's up to you. So if y is less than or equal to 4, I know that it's going to be down here. But I'm not going to shade the whole area. I just know it has to be below there. Okay? X is less than or equal to 5. So at 5 on my x-axis, less than shades to the left. Left and lower. So I know that it'll shade to the left because it's less than. And then my last one says x plus y is greater than or equal to 2. I can't graph that because it needs to be in slope-intercept form. So y is greater than or equal to negative x plus 2. And so I will graph that line, plus 2. With a negative 1 slope. If you do not know how to graph, I will see you in tutorials tomorrow. So since y is greater than, it's above this line. So my feasible region is where all those dots are in the same spot. Yes, it needs to be shaded. No, not completely, but it needs to be shaded. Okay? Questions so far? Is this a bound or an unbound graph? This is a bound graph. Okay? How many vertices does this graph have? 3. So I have 1 vertice, 2 vertice or vertex, whatever you want to call it, 3. Okay? Now, the next part, there is not much room on your paper for, but we're going to make it fit. Okay? So, point number 1 is at negative 2, positive 4. You have to take each point and plug it into this objective function. So I have 3 times negative 2 minus 2 times 4. And so that would be negative 6 minus 8, which would give me a negative 14. Okay? So I'm going to go try point number 2. There's not much room, just make it squeeze. Point 2 is 5, 4. Same function, just with different numbers. So 3 times 5 minus 2 times 4 would be 15 minus 8 which would give me 7. And then we're going to go try point number 3, which would be 5, negative 3. Is it all up there? Can y'all see it all still? So then I'm going to have 3 times 5 minus 2 times negative 3, which would be 15 plus 6, which would give me 21. So your maximum occurred at the point, which one was your maximum? 5, negative 3, which gave me an answer of 21. My minimum occurred at the point negative 2, 4, which gave me an answer of negative 14. I know it doesn't make sense. Like, what does this mean? Okay? I don't care about that today. I care, can we graph it and get the maximum and minimums? When we do the word problems, either at the end of class or tomorrow, it will make sense what it means. Okay? So questions on how to do number 1. All right, number 2, I'll give you a few minutes. I'll push pause on the camera so that you can graph these. That's all I need you to do first is graph them. All right, so to find this, I have a y-intercept of 12, but that's not on my graph. You agree? So instead, I can find my x-intercept. And how I find an x-intercept is I know that my y has to be equal to 0. So if I move my 3x to the other side, I have a negative 3x equals 12. So x would give me a negative 4. So this is my x-intercept. Okay? So I'm going to go to my graph and put a negative 4 on my x-intercept. The slope of my line is still the same, correct? So my slope will still be a positive 3 over 1. So up 3, right 1. Up 3, right 1. And then I can connect my points. Okay. Does that make sense? Do I need to explain it one more time? Explain one more time? Okay. So you understand how to graph this line. Y is less than or equal to 3x plus 12. Where would you normally start? At 12. There is no 12, correct? But I can always find another point because I can find the x-intercept, okay? So how I found the x-intercept, any x-intercept, what do I know about y? It's 0. So all I did is plugged in 0 and solved for x. So I know that my x-intercept is at negative 4, 0. So you have a point and you have a slope. So can you graph a line from one point and a slope? Yes. Okay, so that's what we did. We put our point and then we drew our slope. Okay? All right, and then if you shaded correctly, it should be all this area inside. Do we agree? Okay. Is this bound or unbound? This is unbound, and the reason you need to know that is because it will have a max or a min. It will not have both answers. So an unbound area has a max or a min, okay? So pick my vertices. I have a vertex here. I'm going to call that number 1, number 2. So let's go test those in my objective function. So the point negative 4, 0 is what I'm going to test first. So I have 9 times negative 4 minus 6 times 0, which would give me a negative 36. My second point would be 0, negative 6. So I have 9 times 0 minus 6 times negative 6. which would give me a positive 36. Okay? Now here's the part you really need to listen to. When it is an unbound graph, you have to pick a random point to test. And here's my suggestion. I would pick a random point that is off my graph, but make it simple. Like if I pick a point on this y-axis that's up here, like 0, 8, 0, 9. So pick a point. You can do 2, 7, that's fine. That's just not simple, okay? So you have to pick a test point whenever you have an unbound area. And I'll tell you why just a second. So I'm going to pick the point 0, 10 because I know that will be somewhere up in my shaded area, but off my graph. So I have 9 times 0 minus 6 times 10, which would give me a negative 60. So now, how do I figure out if I have a maximum or if I have a minimum? This test point got bigger negative, which actually is a minimum, correct? So what do you think will happen if I test 0, 12? It'll be even a bigger minimum or a more negative number. So I know that this graph will have no minimum because it keeps going and going and going, and my numbers will keep getting more negative. But I do know that it has a maximum at 0, negative 6, and that maximum equals 36. So these would be my two answers. Do you understand how I know there's no minimum? Do we need to talk about that again?
Yes.
Talk about it again? Okay. When I have an unbound graph, you have to pick a test point. That test point is going to tell you if my graph is getting more negative or more positive. Because it was me and I was looking at this graph, I would think I have no maximum. Do y'all agree just looking at this graph? Okay? But this objective function is what actually tells us the max and the min, not the graph. So I have to pick a test point off my graph in the shaded area. So I picked 0, 10, which would be way up here. Okay? When I plugged this test point into the objective function, I got a negative 60. So let's just watch. You don't have to write this, just watch. If I make my number line, okay, I plugged in a number and I got a negative 36. I plugged in my second vertex and got a positive 36. When I plugged in my test function, my test point, I got a negative 60. So if I keep plugging in test points, will I keep getting more negative numbers or will I get more positive numbers? I'll get more negative numbers. That's what this test point tells me. Okay? So I know that there's nowhere for this negative to stop, which means I have no minimum numbers. It's going to keep getting smaller because this graph keeps going on forever. So my shaded region keeps going on forever. Okay? So, moral of the story here, you have an unbound graph. You need to test a point, and your test point will tell you if I have no maximum or no minimum. That's what the test point is for. Questions? Yes, you only have to do one test point. Okay? All right, so we're going to skip the word problem. We'll do that first thing tomorrow. I want you to turn, and there are 4 problems just like this. So I want you to figure that out. One of those 4 problems is unbound. So if you don't understand this test point, then try to get to number 4 before you leave my class today. Okay?